Bismillah ar-Rahman ar-Rahim. We will continue just the remaining slides from the last session. We stopped at arrays. So arrays is a type that we will use from the NumPy package. There's a package called NumPy. So we will use the arrays type from there. Well, actually, we will use at least the methods that are defined in NumPy to deal with the arrays. Okay? So an array, I think you are familiar with that, is a sequence of values. All elements of an array have the same type. Okay? So all of them are integer or floats or strings and so on. Okay? You cannot have different elements of different types in the same array. And arithmetic is applied to each element individually. As you will see in Python or using NumPy, it is very easy to do processing or to handle the elements in the array just by one command. You don't even need to use any loop commands. Okay, you don't need to use for or while or whatever. We can just with one command, very intuitive command, we can do lots of operations over the array, which means it will be the operation on each element individually. We'll see that inshallah today. Even dealing with multiple arrays at the same time, if I want to add two arrays, it's very nicely used in Python. And it will be done element-wise. Related to the tables, we started to look at tables last time, right? Related to tables, each column is an array. Each column in the table is an array. Let's go through some demos now. We'll start with the demo for the arrays. Okay, so here is, so first we on this, sorry. Here is a way of making or creating an array. So we give all the values in the array with the method makeArray. This will give us an array. Now we have the array 1, 2, 3, 4. Now if we multiply the array by 2, what would happen? Yeah, so that now will be, it's not multiplying the array actually, it is multiplying each element individually by that number. Okay, so we would expect that each value, each element will be multiplied by 2, so we'll get 2, 4, 6, 8. Okay, so you see how easy it is. We don't need to even write a for loop to go through all the elements. And it's very intuitive to write multiplication, okay, as we used to do. If we create another array, now the array, still the array was not changed. Okay, did you notice that? Okay, so the array was not changed, but it created another array. So if I want to capture that, I have to save it into another variable. Okay, this is very similar to what we saw in tables. Whenever we do an operation on a table, let's select columns or select rows, that actually creates a new variable, okay, a new table, not modifying the original one. If we create another array now, and we added, now we can use the addition to add two arrays, which means we will add element-wise. Okay, so the first element in the first array plus the second element, plus the first element of the second array, and so on. So if each corresponding element will be added to the other one. So now, if you notice, now this is 1 plus 5, 6, 2 plus 6, 8, and so on. Okay, so that's the output of adding. Now this is a shorter array, 5, 6, 7. Now what could happen if we added the shorter array to the original one? Now the shorter array has how many elements? 3. The original array is 4. Okay, so you cannot do that. You will get an error. Okay, so the addition has to be over two arrays that are of the same length. Okay, and that's logical. Right? You cannot add two arrays that that are of different sizes.
Add the numbers, the values of each one to
If they are of the same length, then yes, they will be added, as we saw in the previous example. Yes.
not merge them.
No, they will not be merged. You mean addition? Addition will add the values. So the length, and that's a good question, the length now of the output array, and if the two arrays are of 4 elements, what is the length of the addition of them? Also 4. Okay, it's not 8. Okay? Yes. Yes. First here, second here, and so on. How about this one? So this is making another array. Okay, but now the array is strings, array of strings. Okay, if we multiply this array by 2, okay, we saw last time a string, when I multiply a string by a number, it will be repeated, right? So you would expect the same here, but actually it's not, because by definition, this is the interpreter expects that doing this operation, the values have to be numeric. Okay, so you will get an error here. So that's not when you do it on a string, because it is original string. The interpreter knows that it is a string, but here it expects to be a numeric, so it will not be converted into a string, and the operation will not be done. Yes. Okay. So I think last time we had an example of a string multiplied by 2, or multiplied by 100 actually. It was ha, right, if you remember. And that means that the output will be repeated 100 times. Okay, now if we have an array of strings, okay, and we multiply it by a number, that will not have the same effect. Okay, because that kind of operation is available only for numeric values. When it is in an array, it has to be numeric. Yes, no, that's what we did before, right? Or we didn't. Did we do it today? Yes, we did it. Here. Okay, so we did it. Okay, now my array is still the same, 1, 2, 3, 4. I can get the length. I think we saw that before, the length of an array. It is 4, right? And we can, as we saw before, we can multiply by a number. We can also divide by a number. So this will give us, we divided the sum of the array. So here we use 2 functions. The sum of an array, which is getting the sum of all elements in the array, divided by the length of the array, so it will be just one number. But I can also divide an array with a number, which is similar to what we saw in multiplication. So every element will be divided by that number. Can get the average. Okay. So sum here is Python method. Average here is a NumPy method, so I have to use the package NumPy. If you noticed here, we imported NumPy. Okay, when you say import NumPy as something, then this is just a short name. Okay, so you can use np instead of typing NumPy. Okay, so here we used np np.average. It will give us the average of all the elements in the array. Okay, that's another array that we defined earlier. If I want to get one element of that array, we use the method item. Okay, so item 1 will give us which element here? 6, because the index starts from 0. Don't forget, as usual. Okay, the index in the array starts from 0, so item 1 will give us 6. Okay, that of course doesn't change anything in the array. If I want to get the first element, I will use item 0. Here is another way also of indexing, which is usual in other programming languages. Still, we get the same value. Okay, so that's a quick intro to arrays. Any questions about arrays?
Doctor?
Yes.
We call it that the same as NumPy packages?
Yes, data science and NumPy are packages. Yes, we call them packages. And these, I think, will be the two most used in the course, data science and NumPy. Okay, now we'll talk about what we call ranges. So a range is an array of consecutive numbers. Okay, so 1, 2, 3, 4, 2, 4, 6, 8, 10, and so on. So these are examples of ranges. So I can create a range in different ways using NumPy aRange function. Okay, so one form of it is to give it just one number, and that will generate an array of integers from 0 up to the given number, but excluding it. Okay, so we'll see examples. Okay, but remember always that the range starts from a value and ends with a value. The starting value is always included, and the ending value is always excluded.
The size,
No, end is not the size, because the step might not be 1. By default, yes, the end is the size. Okay, but as you will see now, we can specify the start and the end. Okay, and we can also specify the step. Okay, we'll see examples very soon. So aRange start and end, so it will give us an array from start, including start, and up to end, excluding end. And we can also specify the step. Okay, so let's go through the demo here about ranges. So we'll just first make an array from 0 to 6. Now if I called aRange of 6, from 0 to 5, very good. So that's not from 0 to 6, right? So these two arrays are, of course, different. Okay, if I made it 7, it will be from 0 to 6. Okay, so always, if I give just one number, this number will be the end, and it will be excluded, and will start always from 0 by default. Okay, now what if I want to specify the start and the end? Then I use the other form. I use here, for example, 5 and 11. So it will be from 5 to 10 inclusively. Okay. You can try. I don't think, but you can try. Okay. I posted, by the way, all the notebooks. Did you get them?
Yes.
Okay. So please try yourself. Okay. Don't think that what we are doing here is sufficient. Okay, try yourself, try different things, whatever you think you want to explore. Nothing bad will happen if you get errors. Okay. Okay, what do you expect from this one?
Even numbers from 0 to 18.
Yes, from 0 to 18. Okay, so we'll get from 0 to 18, step 2. So 0 to 4 up to 18. How about this one? 0 to 19? How can we get 19 here? 0 to 20. Okay, 0 to 20. Yes, step 2. Okay. And 21 by default will not be included. Okay, so from 0 to 20 step 2. Okay. We can also get floating point numbers. So from 0 to 1 with step point 1. So it will be 0, 0.1, 0.2 up to 0.9. Okay, so we'll get from 0 to 0.9. Okay, this one from 0 to 7. From 0 to 7. Okay, a dot item of 8. Okay, we start from 0. Okay, so item 8 is?
This is the value.
Okay, so the index that we give to item is the actual index. So 8 is out of range here. Okay, so we'd expect to get an error here. Okay, don't forget. Okay, so I think what you said earlier is correct. So if we want to get the last element here, then it will be a dot item 7, which will be 7. Okay, Any questions about ranges? Okay, so the function here is called a range. Okay, and you give it either the end, start and end, or start and end step. Okay. Oops. Okay, so this is the so that was the end of the previous session. So we're starting now a new session about tables. We already talked about tables before, right? What did we study in tables earlier? So what is a table? It's a sequence of rows and columns, right? Each row specifies an information about an individual, okay? And each column is like an attribute, okay? Specific attribute. So there are multiple ways to create a table. One is to read a table from a file, and I think we saw that before. And the file usually is a CSV file, a comma separated values file. Or you can create a table from scratch using the table function. Okay? And we can also create new tables using select or where or sort as we saw before. Let's go through this quick demo. Okay, now we said earlier that each column in a table is an array, right? So to create a table from scratch, you have to create columns, and to create columns, you have to create an array. Okay? So we create an array first with these values. We have 4 values here. We can use table method to create a table. So we to add this column to a new table, we use with column method. So with column adds a table, adds a column to a new table or an existing table. If we have a table already, we can use also dot with column to add a new table. But remember, it will create a new table. Okay, so it will not change the current table. It will create a new table. To save that table, you have to store it into another variable. Yes. US? What? Where is US? U8. So that's UTF-8. That's the encoding. Okay. So south side here will be a table with one column. Okay. When we call with column, we have the label and the values. Okay. The values of that column, which will be an array. Okay, so we'll have to give the name of the table, the name of the column, and the values of the column. Now we have a table of 1 column and 4 rows. Now if I want to add another variable, another column called blocks from campus, and I want just to give it the value 0, 1, 2, 3, then I can use with column with the name of the new column. And since I need just to use 0, 1, 2, 3, I can create it with arange. So arange, remember, arange creates an array. Okay, so now this array will be the values of that column, and I added, I created a new column. Now remember, with column doesn't change the current table. It creates a new table. So if I do this, now this is the returned table with 2 columns. But how about the original one? It will be just 1 column. Okay, is that clear? If I want to store this, to use it later, then I have to assign it to another variable or the same variable. Now I have the same. I have 2 columns if I do that. Yes. Yes, you can do that. So you can, of course, at any time you can do that. Or there's another function called with columns, and you give it label array, label array, label array. Now you can create multiple columns.
But all the arrays
from the same side, right?
What do you think? I think so, yes.
So nothing.
Because you have to have for each row the information to be there. Okay, you can try it. Okay, now you can use labels to get all the labels of the table. So we have 2 columns. So there is a label for each column. Number of columns will give us what here? 2. And number of rows? 4. Okay? Yes? I don't hear you.
The header, she needs the header count.
Of course, the header is not counted. In the number of rows? No, the header is not a row. Remember, the row is associated with an individual, okay, with the information. This is just the header, okay? And it's not, of course, included in the number of rows. Okay, now we'll talk about a real example, okay? And then we play with the data a bit about this example. So this is a very classical example. Some think that this example is one of the greatest visualization graphs in history. Okay, we'll see it in the next slide. So this is a civil engineer, French civil engineer, who created a graph about the Napoleon invasion to Russia. Okay, so the French army at some point in history wanted to invade Russia. So it went through multiple cities. There was a fight there, and then they came back. The graph that we will see in the next slide, you will see so many information on one graph. So you will see the number of soldiers, you'll see the direction of the march, you'll see the temperature, lots of information you will see on the graph here. So let me explain this graph. As you will see, you see the brown curve, okay, the light brown curve, or yellow maybe, okay, you see it? So this is going from the first city, where the number of the soldiers is written here. Okay, I don't know if you see it easily. This is around 400,000 soldiers. So that's the size of the army when they were at that city. Okay, now the width of the curve indicates the size of the army over time. Okay, so at that point, for example, at that city, the number was, this is I think 175, something like that. Okay, or 200? No, I think 175. Okay, so from 400,000 to 175,000. Okay, of course there are reasons for that. Okay, we'll not talk into details, but one of the reasons I think is the temperature. It was very cold, and they were crossing rivers and so on. So the number of they died over time. So marching towards Moscow, they went through some cities until they reached Moscow. Here, the size of the army was 100,000. So they started with 400. Now they are 100. Okay, there was a fight in Moscow, and then they came back. So the black curve is the retreat of the army back to where they started. Okay, and you see, of course, the width of the black curve is much smaller than the brown one, and you will also see the number of the soldiers. Okay, at that point, okay, you see here the number. Some soldiers actually went through that path, and they merged with the soldiers coming back from Moscow at some point. That's why there is an increase here, which is unusual in the entire graph. Okay, so they increased from I think 20 to 50 here because of this addition of part of the army, but still they decreased over time until they are 10,000. Okay, at the end. Okay, so do you see where the temperatures? Down, yes. So this is minus 26, is minus 30, minus 20, minus 21. Okay, it's too cold. It also has you see the curve is not just a line, it's a curve. It is also representing the relative position of the cities. Okay, each city of course has a longitude and latitude. That's the coordinates of the city. So as you see, the graph has number of soldiers, the relative positions of the cities, the direction of the march towards Moscow, the temperature. Okay, so it was really nice graph. Now we can play with some data related to this story, and here's a table that shows us for some cities what was the direction, what was the longitude and latitude of the city, okay, and the number of survivors, which is the size of the army at that city. Okay. Now let's play a bit with that data set. So we'll read it from a file here. So that's the data set that we saw in the slide. Okay, we'll leave that to the end, or actually I will leave it for you as an exercise, but after we go through the other ones. So if I want just to look at the city, I will select the city column. So select city column will give us. Okay, no, it's not an array of cities. It will be a table with one column. There is a big difference. Okay, there's a big difference. And we'll see it actually in the next command. So select will give us a table with one column, which is a city. If I want the array of the values in that column, I use the column method. Okay, so column city will give us an array of these values. Okay, this one is a table, this one is an array. Same if I want the values of the survivors. Now, if I want to compare over time or over different cities the ratio of the survivors relative to the initial size. Okay, and I want to say at that, starting here, and we went to that city, I want to know the ratio of the survivors. How many soldiers survive? Is it 40% of the soldiers, 90, 10? Okay, so I need to get first the initial value, which is the value number 0 in the values in the arrays of the array of the survivors. Okay, so initial size we can get it from the array dot item 0. That's the first value. That will be 340,000. That's the initial value from the data. Oh, not this data. This data here. Okay. And then I want to get the ratios. Okay, so I need to divide each value of this column by the initial value. So we'll do that. We'll get, of course, we cannot do that directly to the table. Okay, this kind of operations have to be done on arrays. Okay, so we need to get the column as an array, then divide, then if we want we can add it to the table. Okay, so we'll now do this first step. We get the array that has the ratios. Okay, so of course the ratio is 1 for the first one. Why is that? Because we are dividing by that number. Okay, look at this number. What does that mean? Yes, 1%. 1% survived. Okay, at that city, relative to the initial size. Okay, now we can add this to the table. Remember, adding a column, we use with column. So we will use with column with a new label, percent alive. And remember, to add a column, we need to indicate the label and the array of values. Okay, and that's the array of values. So we add it to the table. Now the table has a new column which is percent alive. And you see here that this number is very, very small. Okay, looking at ratios is better when we see percentages. Right? So we would like to see 1% instead of 0.01. So there is a way to do that using the set format method. So still we are using a method on the table. Set format, we give it the specific label, specific column that we want to convert into a percentage. And we use, of course, because we use percent formatter, we give it the name of the column that we want to format. And that's a specific formatter called percent formatter that will convert the values from ratios to percentages. Okay? So if we do that, you will see that now this column is in percentages. Okay? So basically multiplied by 100 and then put a percent character. So you'll see here 100% going to 51, 16, here it's 1.18.
And what is
Yes.
the percent formatter? Is it a variable or a function?
It's no. This is like a method. It's a type within, I think, the data science package. Okay, that later in this lecture you will use another formatter. So there are multiple formatters you can use to format a specific column. Okay, so that's like a class, another class in the data science package. Now, if we get that column using dot column and the name of the column, what would we get? Yes. And what are the values? Are they ratios or percentages? Okay, so the actual values are ratios. Okay, so the formatter doesn't change the values themselves. Okay, it's just the way it is displayed, but the actual values are still ratios, of course. Okay, between 0 and 1.
I want to save it as a person.
No, then you have to multiply by 100 yourself. Okay.
While we are doing the percent formatter, we can save the
No, okay, so that will not change the value. This is just a formatter for displaying, but the actual values will not change. If you want to make them ratios, then multiply by 100 and deal with them as percentages. Okay, now this is a very helpful function. Okay, called help. So whenever you want to know more about a specific function or specific type, okay, or class, we can use the help function. Okay, so this is like you will get the documentation for that function. So if we use that, you will see a very nice documentation, including the meaning of the arguments, even with examples with numbers. Okay, so you'll see example. Really detailed examples with different ways of calling the function and so on. Okay, so please use that whenever you want to know maybe the meaning of the arguments, how it is used, this function, and so on. Do you have a question, Amina? Okay. Okay. Any questions so far? Okay, so we'll move on. So we know that we can create columns with column, and we can create a table with read table. And with column also, it's not actually creating, it's not creating a column, it's creating a new table with the new column. Okay, after we add the new column. And the table, of course, it will read from, it will create a table from a file.
With column, create a new table.
Okay, so it starts from a table and create a new table with a new column. Okay. Finding the size, we can use number of rows, the number of columns. Referring to columns, we can use the labels, or you can use the indices, by the way. We can use 0, 1, 2, 3, so the columns are indexed also, or starting from 0. So instead of using the label of the column, you can use the index. Okay. In any position you are using the label, you can, instead of remembering the name, exact name of the label, of the label of the column, you can just use the index of the column. As we saw last time, we can relabel, okay, the column. Accessing data in a column, we said that we can use column, but column will return an array. We can also deal with, now we can, if we get the array from the column, we can use the array methods like item, sum, min, max, and so on to deal with the values in the array. Creating new tables with some columns, we can use select and drop as we saw before. Okay. Let's go through this quick demo about selecting data in column. So this is a data set that indicates for each year, okay, from 2015 and beyond, how many movies, that's data about the US, how many movies in this year, how much money paid in tickets for all of these movies, the average ticket price, and the top movie in that year, probably by the number of tickets sold for that movie. And we have this for so many years. Okay, so this is the data set about movies. Now let's play with it. First, I want to get the number of tickets sold per year. So we have the total money, and the average ticket price. How can we get the number of tickets? Yeah, divide the total money, divided by the ticket price, we'll get the number of tickets, right? Okay, but before doing that, we have to convert that to the actual amount of money, because that's not, of course, in dollars. So you wouldn't expect that the entire American people paid only 11,000 in the whole year. Okay, so these numbers actually are in millions. These numbers are in millions. Okay, so in order to do this operation, we have to convert it into the actual number. So how can we do that? Multiply by 1,000,000. Okay, so multiply this column with 1,000,000. How can we do that? We used column, we get an array, then multiply by 1,000,000. Now we get an array with the exact numbers. Okay, now how can we get the number of tickets? We divide that new array by the average ticket price. Okay, and that's what we do here. Okay, look at that. So movies.column, total gross, times, what's this? That's in the scientific notation, the 1,000,000. And
So we always write in the scientific notation?
no, we don't have to, but this is shorter, right? Instead of counting the number of zeros that you write, you can just say 1E6, this is 1,000,000. Now we have an array with the exact numbers. Now what are we doing here? So gross in dollars divided by movies.column average ticket price. So what are we dividing actually here? What are the types of the two sides of the division? No. The type of, what is the type of gross in dollars? An array. Very good. It's an array. What is the type of movies.column? Average ticket price? It's an array also. Okay? So we are dividing two arrays. Okay, what is the meaning of that?
Dividing the values in there.
I understand, but it's dividing the values it's element wise. Okay, so the first value here divided by the first value here there, the second value here divided by the second value there, and so on. Okay, and this will return an array. Very good. Now, if we want to add it to the table, we use with column to add it to the table. Okay. So up to this point, we'll get the array of the number of tickets. Okay. Can you tell me what is this number? So what's 1.3 times 10 to the power 9 billion. Yes, so this is 1.3 billion tickets sold in the year 2015. Okay? If I want to get the average number of tickets per citizen, how can I do it? Per citizen, per person, per US citizen. Divided by the population, right? Okay, now you can, if you do that, you can see how many tickets, how many movies the US citizen is watching in 2015 in average. Okay, if I want to add now this, so far this is an array that's completely out of the table. Then I can add it to the table. I can use with movies. Now movies, because we assigned it to movies here, it is added to the table now. And if we show the first four rows, we get tickets sold here. Okay, but
did we modify the original table?
Did we what?
Modify the original table.
Yes, because we assigned it to movies again, back. If we didn't do this assignment, it's a new table, and it will be gone after that command. We didn't capture it in any variable. Okay. Okay. Looking at these numbers is not nice, right? With this plus, with this scientific notation. So we can use another formatter, and this is related to your earlier question. We use set format, and we use a number formatter in this case. So let's see what number formatter will give us. Look at the numbers now.
The previous one was percent formatter?
Yes. What is the formatter here? So it's just putting commas, right? Every 3 digits to show us easily the actual amount. Okay. So up to here, it is in thousand. This is in millions. This is in billions. So it is now easier to say 1.3 billion. Okay. Now, if I used column, it's still the same, as we said that the formatter will not change the actual values. Still in the same format, same value. Now, if I can also plot the relation between two columns. So I can plot years with tickets sold for each year. How many tickets were sold? This is the column that we just created. So we'll see this nice plot. So you'll see that the number of tickets is increasing. Okay, and then it is decreasing. It is very hard to do that without the operations that we did and without plotting. Okay? Now, it is very clear that there is something happened At that time, yes.
It's for different movies, right?
It is what?
For different movies.
These are for different years, not movies. Of course, each year has maybe different movies, yes. Or the same movie. Sometimes the same movie is displayed over years. It can be. But we don't care about that now. We care about how many tickets were sold per year. That's what we brought here. For each year, how many tickets? So it seems like this is increasing over time up to maybe 2002, and then decreasing up to 2015. Okay? There must be a reason, right? So we can guess. Any guesses?
The population increased?
Decreased.
Increased.
No, it has.
The price is available.
So if the population decreased, you would expect that the number of tickets would decrease, right? You mean that okay, but if it increased, then the number of tickets should increase, right? But the movies are the same, maybe. Okay, but yeah, I get your point. But why did it increase only here? Okay, it's and I don't think this is the case. Okay, we can verify that easily if we have the population over years, and this data is actually we will play with this data next lecture, the population over years. Okay, but that's not the case. That's not the case.
Maybe the people learned how to leak movies.
Yeah, one of the reasons, one of the guesses, okay, here is that yes, a new technology appeared at that time, and you don't have to go to the cinema and buy tickets. Okay, why don't we use YouTube? Even if this is legal, by the way, they don't have to hack and get to watch movies illegally. But maybe the new technology happened, or maybe the interest of people changed because of some events. Okay, around that event, that time, I think there was the 9/11. Okay, so maybe people didn't watch movies as much, and now they are watching. Now they are maybe paying more attention to TV channels. Okay, but the point here is that looking at the data, playing with it, plotting it or visualizing it, will give us some insights. Now, we saw that there is something weird here. We go and maybe study why that happened. Okay? And as we said earlier, the data scientist should not work in isolation. So maybe we need to, at that point, we need to consult with domain experts, okay, about the industry of movies, in that case, and study why that happened. Because it's a very clear trend, right? It was increasing up to that point and then decreasing. So there must be something behind that. The cause of that, if you remember the causality issue. Okay? We can also plot the number of movies per year. Okay, it's almost stable. So that's not maybe the factor here. And here is ways of selecting rows. I think we can look at that next time.